This video will be about volume, surface area, and changing dimensions. So if we're going to find the volume or the surface area of a shape, we need to know what they mean by each shape. So first, we have a rectangular prism. This basically is a box. So with a rectangular prism, we can find both the volume and the surface area. We need to label the sides though. Let's say we have length, width, and height. So the volume is how much you could fit inside. If this box had an open top, how much could you fit inside the box? So volume of a rectangular prism is length times width times height. Surface area is how much cardboard would you need to make the box itself? How much would you need on the outside pieces of the box? So surface area of a prism is 2 times length times width plus 2 times length times height plus 2 times width times height. So it depends on what they're asking for. If it asks for a volume, we'd use the first formula. If it asks for a surface area, we'd use the second formula. And they would just put numbers on the shape, or it looks like on the assignment they didn't even draw the shape out. It just said the length, the width, and the height were these numbers. So if we had 6, 5, and 8, the volume would be, we know our length is 6, so 6 times, the width is 5, and then the height would be 8. Sorry, I wrote H instead of 8. And then we'd multiply all those together. 6 times 5 times 8 is 240. And then if they give us units, if these were all measured in inches, we would have inches cubed because we multiplied three things together. So related to a rectangular pyramid or prism is a rectangular pyramid. A rectangular pyramid is going to have a base that's still a rectangle. I'm going to draw the back line dotted. And then it goes up at a point, connects together to look like one of the Egyptian pyramids almost, although those were squares instead of rectangles. So same idea, it has a length and a width. And then from the center point down to the middle is the height. So rectangular pyramid is almost the exact same volume formula. It's still going to be length times width times height, but it's also going to have times 1/3. A rectangular pyramid is 1/3 its corresponding rectangular prism. Surface area they don't normally ask you about, and they don't ask it on this particular assignment, so I'm going to skip surface area of the rectangular pyramid. Next we have a cylinder. That could be like a soda can, any shape that looks kind of like a cup. So our cylinder has a radius. Sorry, I don't know why that box keeps popping up. The radius is from the center of the circle to the outside, and then a height of how tall the can is. So the volume of a cylinder is pi times r squared times h, and the surface area is not 1/3, I was looking at the wrong formula. the surface area is 2 pi times r times h plus 2 pi times r squared. So, if I had a cylinder, let's find surface area this time, and it had a radius of 6 centimeters and a height of 9 centimeters. So, finding the surface area, we'd plug each of those in. We know 6 is really the radius, 9 is the height. So we'd have 2 times pi times a radius of 6 times h, which is 9, plus 2 times pi times the radius squared. The radius was 6, so 6 squared. Now, calculator-wise, some calculators have a pi button. If not, just use 3.14, the approximation for pi. So again, once we plug this all into the formula, we would go just plug it into our calculator. I am going to be using 3.14 and not a pi button. Gives us 565.2. Now, area, when we use units, would be centimeters squared. So related to a cylinder is a cone. You probably have seen traffic cones at some point. They are in the shape of a cone. A cone still has a radius on the circle, and then from that center point it has a height. So a cone, again, we're only going to do the volume of a cone. It will not be asking you about surface area. The volume of a cone is similar to how a pyramid was related to a prism. It's 1/3 times the volume of a cylinder. So 1/3 times pi times r squared times h. So then the last formula would be for a sphere. Basically, a ball. So on a sphere, we only need one piece of information. We need the radius. And the formulas for a sphere, the volume is 4/3 times pi times r to the third, so times the radius to the third, and the surface area is 4 times pi times r squared. Again, you can use 3.14 for pi. Let's say the radius was 7 meters. If I were to find the volume of a sphere with a radius of 7 meters, I would have 4/3 times 3.14 times the radius, so 7 to the third. When I actually go plug this into a calculator, we're just going to plug in 4 divided by 3 times 3.14. And then there's 7 to the third. That means multiply 7 times 7 times 7. So if we go plug this in, that would give me 1,436, that's a comma, 0.03. Again, we have units. This is a volume. Volume was to the third, so meters cubed. Sorry about that. Meters cubed. So those are all the formulas you would need on the assignment. The other thing it talks about is changing dimensions. Let's say you have a volume that's 537 inches cubed. And let's say your volume, the sides of the shape, were shortened. Let's actually not say shortened, let's say tripled by 3. So we have some sort of shape. Doesn't even matter what it is. I'm going to stick with a rectangular prism just so we have something to look at. Right now we know if we filled up this prism, if we filled everything on the inside, that would be 537 inches cubed. We don't know what the sides are, but we know we're going to triple the lengths of the sides. We're going to make this shape bigger. Well, the volume doesn't change by the same amount. It's not going to just triple. That's because each side is going to affect what happens. If I said this was length times width and height, well, each side is going to be tripled. 3 times length, 3 times width, 3 times height. So when we go to find the volume, we'd have 3 times 3 times 3 times length times width times height. All those 3's are going to affect it. So that means instead of multiplying the volume by 3 like we multiplied the sides, we're going to have to multiply the volume by 3 times 3 times 3, which would be 27. So to find the new volume, I would multiply the old volume by 27. So 27 times 537 is 14,499 inches cubed still. So if it's going to triple the sides, we actually have to multiply by 27. If they were going to give a surface area, surface area is only squared. Let's say we have 210 centimeters squared. If we were going to do the same thing and triple the sides with our surface area, that means we're only going to need to do it twice. Instead of 3 times 3 times 3, we only have 2 of them because it's surface area. And since it was tripled, we're using 3. So if it had said doubled, we would use 2's. Or if it had said quadrupled, we'd use 4's. So surface area, we use 2 of them. If it had been volume, we use 3. And if it was just the sides themselves, we'd only need to triple it. So 9, that means 210 is going to have to multiply by 9 to get the new surface area. If we triple the sides, it actually changes the surface area by 9. So 1,890 meters squared. So that concludes our discussion on volumes, surface area, and changing dimensions.